Hello guys, welcome again sa ITS, Information Technology Skills. On this video, pag-usapan natin on how to compute the time complexity of a Fibonacci sequence in divide and conquer. So let's start. This is the sample algorithms of a Fibonacci sequence in divide and conquer. Meron po tayong function named fib and it will accept a variable n. And if the value of n is less than 2, it will return 1. Yung Fibonacci kasi guys, it always start with 1. Then, ipa-plus niya yung previous niya. That will be the next element. So, then the previous of 1 is 0. So, 0 plus 1, another is 1. The next is 2. The next is 3, and so on. So, that is a Fibonacci sequence. Kaya po, meron po tayo ditong condition na if the value of n is less than 2, it will return 1. Then, it will call again itself. Yung sa calling niya, meron tayong dalawang call. It will call itself n-1 plus fib n-2. So, this is the sample algorithms of a Fibonacci sequence. So, if we're going to compute the time complexity, kailangan muna natin i-compute kung ano yung magiging equation natin or yung gagamitin natin mamaya. So, meron tayo ditong function. So, consider natin yan as t of n. So, t as time. Then, n is the element na ipapass natin sa kanya. Then, meron tayo nung condition. The time complexity of this condition is 1. Then, this part, return 1. So, same lang din naman sila. The time complexity is 1. So, wag na lang din natin siyang isama. Doon tayo sa call. Dito sa calling, we have the first call is fib n-1. So, we're going to have t of n-1. So, saan natin nakuha? Andito po, si t of n. Tapos, magma-minus 1 lang tayo. Plus, meron tayong fib n-2. So, meron tayong t of n-2. So, same with this part. Hindi na natin sinama yung 1 kanina. The time complexity here is 1. Pareho lang din dito. So, we're going to consider that t of n-1 is equal to t of n-2. So, kapag same sila, gawin na lang natin to si t of n-2 as t of n-1. So, magkakaroon tayong t of n-1 plus t of n-1. So, meron tayo nung equation na to. Bakit ganyan? Kasi, sabi ko nga, we're going to assume that t of n-2 is the same or equal to t of n-1. So, ganyan na lang para konti lang yung binibilang natin or iniisip natin. So, if we have t of n-1 plus t of n-1, meron tayo equation na 2t n-1. So, ngayon, i-add natin tong dalawang to. Pag in-add natin yan, meron tayo ng equation natin, t of n is equal to 2t n-1 plus 1. Okay? So, analyze lang natin tong algorithm na to. If the value of n is less than or equal to 1, it will return 1. So, ibig sabihin, 1 yung time complexity niya. But if the value of n is greater than or equal to 2, 2 pataas, we're going to use this equation. T of n is equal to 2t n-1. Okay, saan na naman napunta si plus 1? Tinanggal ko na lang siya, guys. Okay? So, bakit natin siya tatanggalin? If we're going to follow the rule of time complexity, we're going to remove the constant. So, tatanggalin na natin yung constant dito na 1. But hindi natin tinanggal yung 2? That is a constant. But hindi natin tinanggal yung 1? Because that is part of the equation. Hindi pa siya separate sa isa't isa. Ito, nakaseparate na siya. Okay? So, we have this equation. If the value of n is 2 pataas, gagamitin natin tong equation. Using substitution method, kakompute natin si time complexity. So, ulitin lang natin. If the value of n is less than or equal to 1, the time complexity is 1 or it will return 1. If the value of n is 2 pataas, we're going to use yung na-compute natin na equation kanina which is t of n is equal to 2t n-1. So, ngayon, kapag gagamitin natin yung substitution method, sa-substitute natin to t of n-1. Hindi pa natin alam yung value niya. So, para makuha yung value niya, analyze natin to. Si t of n, let's say, meron yung minus 0. So, any number minus by 0, that is the same with the number. Kaya meron siyang ganyan. So, minus 0, same lang din. So, yung si t of n-1, magkakaroon tayo ng 2t n-2. Ba't siya naging ganon? Kasi, kung ito, 0, mag-increment ka ng 1, mag-increment din yung nasa loob niya ng 1. Okay, now, we're ready with the substitution. Substitute na natin. We have here the initial equation. Pag sinubstitute na natin, meron tayo ng 2 and the value of t of n-1, which is this. So, meron tayong 2t n-2. Pag kinompute natin yan, meron tayong 4t and minus 2. What if meron tayong another recursion? So, kailangan ulit nating hanapin yung value ni t of n minus 2. So, balikan natin to. Kung ito, minus 0, minus 1, so si t of n minus 2, mag-increment lang din yung mga nasa dulo. That is equal to 2t and minus 3. Okay? So, ready na tayo mag-substitute dito na part. Meron tayong for the value of t of n minus 2, which is 2t and minus 3. Kunin na natin yung sagot. We have 8t and minus 3. What if meron ulit tayong another recursion? Kailangan ulit natin yung value ni t of n minus 3. So, another increment here. Meron tayong t of n minus 3. That is the same with 2t and minus 4. So, kung mapapansin nyo, nag-increment lang yung mga mina-minus natin. Okay? So, substitution ulit tayo dito, guys. We have 8 times 2t and minus 4. We're going to have 16t and minus 4. And so on. So, analyze natin, guys. Kailan ba magiging 0 itong part na to? Ba't kailangan natin siyang i-analyze na 0? Kasi kapag yung nasa loob ng parenthesis is 0, masasabi na natin na it will return 1 because 0 is less than or equal to 1. Okay? So, kailan siya magiging 0? Kung titignan natin yung mina-minus natin dito, meron tayong minus 1, naging minus 2, naging minus 3, naging minus 4. So, those are constant numbers na nag-i-increment. So, we're going to consider that as K, C, or any variables na gusto nyo, or any letters na gusto nyo. Bahala kayo. For me, I will going to use K na lang. Kailan siya magiging 0 yung sagot dito? Kapag the value of K is equal to N. Isipin mo, N minus N, or 5 minus 5. Ang result na is 0. So, magkakaroon tayo ng t of n minus n. 0 na po yung sagot nito. Tapos, meron tayong 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. So, kung titignan natin, yung exponent nila, halos same sila dun sa k. Just like this, sa 16. 2 raised to 4, which is yung k natin dito is 4. So, pwede natin sabihin yon as 2 raised to k or pwede ding 2 raised to n para same siya dito sa mga elements natin dito or yung variables natin dito. Ngayon, alam natin that t of n minus n, it will give you 0. So, pwede na natin yang tanggalin. Okay? So, ang maiiwan is si 2 raised to n. So, we can say that the time complexity of this Fibonacci sequence or algorithm is big O of 2 raised to n. So, ngayon naman guys, gamitin natin ang 3 method. Okay, so for example, the value of n is 5. So, ito yung una nating ipapass dun sa function natin which is the fib. Okay, so the first call is fib5. Then, kung maalala nyo, meron tayong dalawang call which is fib n minus 1 plus fib n minus 2. So, dito, meron tayong fib4 kasi n minus 1, that is 5 minus 1, magiging 4, and fib3 n minus 2. Then, dito sa fib4, meron siyang call ulit yan. Meron tayong fib3 and fib2. Okay? Next, meron tayo ng fib3. Meron siyang fib2 and fib1. So, kung makikita nyo, nagma-minus 1 ako dito sa my left side and minus 2 dun sa right side. Kasi yun yung makikita natin dun sa algorithm. Then, dito sa fib2, meron tayong fib1 and fib0. So, alam naman na natin kapag naging 1 and 0 yung value ng n, magre-return na siya ng 1. So, ibig sabihin, mag-stop na yung algorithm or yung call ng functions. Okay? So, ditong part, nag-stop na yung call ng function. Then, dito, fib1, stop din yung call ng function. Then, dito, hindi pa tapos mag-call si fib2, magko-call ulit siya ng fib1 and fib0. So, meron ulit tayong 1 and 0, stop yung function. Dito kay fib3, wala pa ulit siyang call. Meron siyang call na fib2 and fib1. So, stop na dito na part, kay fib2 na lang. Kay fib2, meron siyang fib1 and fib0. So, yun po yung mga calls ng functions. Kung makikita nyo, yung mga leaf nodes or yung mga leaf part ng tree natin, ang last niya is 1 and 0. So, those are the outer leaf. Ngayon, ilang beses siya nagko-call? Kung titignan natin, dito na part, 2 beses. Kay fib3, 2 beses. Kay fib2, 2 beses. Same with the others. Tigda 2 beses. So, yung call ng function niya is 2. Itong nasa taas, that is the first call, the second call, third call, the fourth call, and the fifth call. Okay? So, 1, 2, 3, 4, 5 beses. Which is ganun din yung bilang nung n natin. So, pwede natin sabihin na 2 raised to n. Bakit 2 raised to n? Kasi yung depth ng tree natin is 5. Okay? So, meron siyang call dito, call, another call, and another call. So, 5 times siyang nag-call ng sarili niya. And every call niya, dalawa yung kinocall niya. So, with that is 2 raised to n. With this calling, pwede natin sabihin that the time complexity gamit tong tree method is big O 2 raised to n. Okay? So, same dun sa una nating na-compute. Kung nakatulong tong video na to, don't forget to like. And kung gusto mo pang matuto about computers, don't forget to subscribe and hit that notification bell for more tutorial videos. Bye!